The 20th question is the last question in the EOT for the Grade 10 Elite. This is to solve exponential equations in one variable. Now here we have real world problems or reasoning problems as well. Now look at this problem. They have given us solve 16 to the power 18 1, 2, 3, 4, 5 times and equal to 4 to the power x. How would you do this? Plenty of methods. You can take log, this, that, and all. But the first thing is we need to differentiate certain things. Now, if you have a to the power x multiplied by a to the power x, what happens? We do x plus x. The powers add up. But now if you have plus here, let me write it separately. Sorry. If you have a power x plus a power x, then it is not the same. Here what happens is, it will be a power x, it will be 2a power x. Now here we have 5 times 16 power 18. 5 times 16 power 18. This is the concept over here. That is equal to 4 to the power x. Now how would you solve this? Here, you can simplify this and take the root and stuff. But there is a log method. This is a very easy problem if you take log, natural logarithm, because these sort of problems, right, are so easy to solve in log. I will just see what is the method used over here. Okay, they have used the graphing calculator method, which is not available. And I don't think so in your calculator this will be giving you any answer. So this much is correct, but then graphing calculator is used and done. But if you don't have graphing calculator, this is the easy method. What is the base of the exponential? See, this is exponential. X is there. The base is 4. Take log base 4 and whatever is the value here, 5 times 16 to the power 18, that is equal to log base 4x. Now you should just remember so much, because when you study log functions, you will learn a lot about this and you'll understand well. But now, as of now, just remember this. You can put this directly in calculator, but right side what happens is whenever the base of the log is same and this is same, it is 1. And this whatever is there comes down. It will be x log base 4 and 4. It will be log base 4 and 4. This term is 1. Okay, because that is the rule of the logs. So for now, just remember, whenever you have x over here, take log on both the sides. Provided the base of the exponent is 4, take log base 4. And this is 1, so it will be x. This side, just put it in the calculator. Let's do it. I'll show you how to do it. All you need to do is press this symbol. Log base 4, 5 multiplied by 16 to the power 18. What is the answer? It is 37.16. That's the final answer. Yes, that's the correct answer. If you have graphing calculator, then you'll directly get the answer as well. But since you don't have, we can use this. If you don't have, sorry. What would be a more beneficial change to 5-year loan at 8% interest compounded monthly, reducing the term to 4 years, or reducing the interest rate to 6.5 for 5 years? Now, I hope you recall the compound interest formula. This is important. Let me just write it out over here. It is always y equals, you can write it in different ways. Principal amount multiplied by 1 plus r by n, the whole power nt. This is the formula. This is called the compound interest formula. This is used in banking generally, where, say for example, a company has taken a loan from the bank and they'll calculate interest and all that, how much payments should be done, all in this formula. Now we can see many things are given. This is important to understand. It's a 5-year loan. That means you will have 5 years to pay back the loan. Okay. But when you pay back for 5 years, wait, let's read over here. 8% interest compounded monthly, reducing the term to 4 years. But if you pay 8% interest every month, then it's compounded monthly, but the term is reduced for 4 years. In 4 years, you can take it off. But otherwise, you must pay at 6.5. If it's 5 years, it's 6.5%. But if you make it 8% interest, the term is only 4 years. So within 4 years, you will give back the money. So the interest is increased. As the years reduces, the interest increases. Now let's apply the formula in both the cases. Here, first one, the final answer will be principal amount is unknown. Let's keep it like that. 1 plus what is R? R is the rate. I will do for 4 years first, okay? This is for 4 years. 1 plus R is 8%. Compounded monthly means n value is every month in a year. So it is 12 because every year it is compounded. So n is 12. The power 12 times t is how much? 4 years. Now if it is 5 years, the same formula, only thing is the p is unknown. It will be 1 plus the rate of interest changes 6.5% divided by 12. And over here it is 12 times 5. Now let's put it in the calculator and see. Solve them in the calculator directly. Only P, leave it as it is, the remaining part. Here all you need to do is say, just put this up, 1 plus 8%, that is shift and this symbol over here. Sorry, shift and this symbol over here. Divided by 12, close the bracket, power 12 times 4. That's the first part. The answer is 1.375. You can just write it over here, 1.375. And I will do the other one also, and then I'll write it together. The years is 5, and we have over here 6.5. The answer is 1.382. See, let's just go to the answers. 375 and 382 times the principal. So now which is greater and which is smaller? If you pay for 5 years, it's going to be 1.38 times whatever the amount of principal. If it is 10,000, it will be 13,000 ultimately when you pay back after 5 years. Whereas, no, sorry, 13,800 something. Whereas if you take it for within 4 years, it will be 13,700. You're going to save a little bit. If this is less than this. So reducing the term will be more beneficial because ultimately when you pay 4 years, it will be this multiplier. So it's lesser than the other one. That's the answer. That's it. Now another problem over here is about to determine the following statements are sometimes, always, or never true. Explain your reasoning. Now this can be solved in different ways. Let's see over here. You can see 2 to the power x is greater than minus 820x. Okay, for all values of x. How would you solve this is, for all values of x. Now, whenever you have exponent, anything, x can be any value. It can be negative, positive, 0 or anything. What happens? You will get a positive answer only. It will be more than 0 no matter what, because the exponential graph, sorry, that is a very bad line. Let me just draw a straighter line. The exponential graph is like this. It's always positive. You'll never touch this axis. Why? It is 0 is an asymptote. So it's always range values. Y values are always greater than 0 no matter what. So here, for all values of x, this will be positive. This part here, 80, 20 to the power x, doesn't matter what, it will be positive itself. But there is a minus sign outside the exponent. So minus into plus is what? It will be minus. Plus will be always greater than negative sign. So it is always true here. So this will be always true. Why? Because 2 to the power x will be always positive. Here, this part will be positive. 8, 20 to the power x will always be positive. But this minus sign is there, so it will be negative, always negative. This part is always positive, but minus is multiplied, so it's always negative. So, yes, 2 to the power x will always be greater than this other term. Always true. Now, here we have about the graph of an exponential growth equation is increasing. See, what is this growth equation? Growth means this b value is always greater than x, right? So, imagine you have this. Growth is something like this. Okay, that is exponential growth. Now, what is decay? Let's do this also. Decay is like this. It comes down, okay? Like this. So, this is the exponential graphs. If it is growth, it goes up. If it's decay, it's going down. The graph of an exponential growth is increasing. Yes, it's always increasing. Whereas the graph of exponential decay is not increasing, it's always decreasing. When this b value is less than 1, the graph is downwards. You can check it in Desmos. You can put y is equal to, say, 2 to the power x. And then that is a growth function, okay? Growth, g. Whereas if you put y is equal to 0.5 to the power x, this is decay, it will come like this. So this is always true. This, 1 minute. I thought of editing the previous part, but I'll keep it because it's a very important lesson, because I just forgot this A term altogether. I was just thinking about growth and decay. That's it. But look here, there is an A term. Now, what happens? Because I was thinking it's like y is equal to 2x, that's it. But A is there. Now, if this A value is positive, yes, it's a growth like this. But what if A is negative, negative 2x? This one decreases. It's like this. If this is the x-axis in the middle, always it will go up when it's positive, going down when it's negative. So it's sometimes true, yes, sometimes it will increase, but if a value is negative, it will always decrease. This is the concept. Now, even for the decay, it doesn't decrease always, it is increasing. Yes, it will increase as well. Now I'll tell you why. Because when, now over here, when it's a decay, it will be like this, right? It will not touch, it will be exactly like this. It's going down, down, down. It will almost touch here. This is a decay function. This is decreasing. It's decreasing, it's not increasing. But if a value is negative, it's minus 0.5 to the power x, then what happens? It flips. It's like this and it keeps on going. It will keep on increasing. The graph increases. You can try this in Desmos. You can try y is equal to 0.5 to the power x. You know the basic understanding of decay is always downwards, but if you put minus, it will come like this. This is the reason both the problems, sometimes they are true, sometimes they are false. Yes, in certain conditions it will increase, but certain conditions it will decrease. Even over here, this will be sometimes true. That's the answer. Now write an exponential inequality with the solution of x is equal to exponential inequality. X is equal to less than or equal to 2. So what you can do is you can just take any power to anything, because it'll be the same. So you can just take e to the power x will be less than or equal to e to the power 2. Now, I mean, you must do let's just check the answer. You must do the operation on both the sides. Now here, x, so, sorry, wait, let me just, I took e value, Euler's number. No, you can't take, because e value is more than 2.2, it is 2.7 something. No, sorry, you can, doesn't matter. See, what you're doing is just take both the sides, take this two things to the power of both the sides. This is basically this. If you take 4 to the power x less than or equal to 4 square, the inequality will be maintained, okay? So it is just that this has a solution. That's it. You can use, but basis must be same. That's the only concept. I'll just tell you why. Because if you have, say, for example, 2 to the power x plus 3 less than 2 to the power 5, we have this power. As long as the bases are same, we can equate the powers, right? We can write it as x plus 3 less than 5. We know this concept. So same way, use same bases. Instead of this, you can even take 5 to the power x less than or equal to 5 to the power 2. This is also fine, okay? That's it. That's what I meant at the beginning. Take power on both the sides, right? That's the concept. And over here we have an exponential problem where we need to solve. Now, over here, to solve this problem, you need to know certain things. Whenever this particular problem comes, what I do is I always write certain numbers. 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. 3 to the power square, 3 to the power 3, 3 to the power 4, 3 to the power 5. Same way with 4 square, 4, 3. At least you should know 2 to 3 values. Till 4 to the power 4. Now I'll just write it over here. Why I'm writing this is you need to know this in your mind. 2 square is 4, 2 to the power 3 is 8, this is 16, this is 32. What about 3? It is 9, 27, 81, 243. Now here is the same thing, 16, 64, and then you will get 216 and so on. Okay. 5 square is 2, 5 square is 25, 125, 625 and so on. Over here you will have 36, then you will have 600 and something, and it goes on. Okay. Now why I'm telling you this is, look here, whenever you see these numbers a set, they always will give you within this range. Okay, within this range, within this also range, not more than that. Now I know 27, 81, 3, 9 all can be written with the same base. This is the most important thing. Now if you know this much, then you can reduce all of them into the same base. Okay, now what does this mean exactly? I will write 27 into, instead of 27, I'll write 3 power 3. And then I'll write the exponent, what was originally there as a power. 3 to the power 4 is 81. Then write x plus 1. 3 as it is, base is same, 3 power 3 only, okay? 2x plus 2 multiplied by 3 square the whole power 4x plus 1. Now we can simplify. The powers, I will write something over here. If you have a, m to the power n, sorry, it is n, okay, or xy, you can take anything. And if you have a power m multiplied by a power n, the difference is over here you multiply the powers. When power to power, it is a m times n, whereas over here you add up the powers, m plus n. When the base, there are two bases. Now here what you do, you multiply the powers. In the sense, it will be 3 times 2 is 6x multiplied by 3. Now this 4 will be distributive property, okay? It's not just for one term, it's distributive. So it will be 4x plus 4 equals 3, 2x plus 2. And lastly, we have 3 again distributive property. It will be 8x plus 2. Now all the bases are same, so equate whatever is the power. 6x. Now, okay, one more thing. Before we equate it, I've just written this rule. When you have same base and you have two different powers, you add them up. 3, 6x plus 4x plus 4. That is equal to 3, 2x plus 2 plus 8x plus 2. Now let's simplify this. 3 over here, what is it? 6 plus 4 is 10x plus 4. And 3 over here, 2 plus 8 is 10x plus 4. Now this bases are same, so you can equate whatever is the power. 10x plus 4 equals 10x plus 4. And now over here what you do is you simplify, take it to the other side. Now here 4 cancels, divide 10, and also x cancels. Okay, it is basically 1 equals 1. It's an identity. All the time it's true. Both the sides are absolutely true because you're getting both the sides as same. So this is true. Okay, now see, we got the same thing, but here they are simplified it further and just kept x equals x. Both the sides are same. That's it. And then we are in the last problem. If you are given the initial and final amounts of a radioactive substance, initial and final, and the amount of time that passes, how would you determine the rate at which the amount was increasing or decreasing in order to write an equation? Now this is an formula. Okay, rate formula. It's given by y. Final amount is equal to the a initial amount times okay, rate is given as r power the amount of time, r power t, I guess. Okay, increasing or decreasing the time interval. Yes, the amount of time that passes. So this is the equation. So here y is the final amount. Okay, final value. A is always the initial. Okay, initial. The r value is the rate. R is rate, r over here, and t is the time interval, time. Now here, if you have been given the initial, you have been given the initial, sorry, A and the final, A and Y is there with you of a radioactive substance, and the amount of time, the T is also given. How would you determine the rate at which the final amount was increasing or decreasing? So you need to find what? T, right? How would you find to determine the rate at which? Sorry, time is given. You need to find R. So let's solve for R. Sorry. This is also given, only R is unknown. So first take the A and divide it, because this is an exponential function. It will be Y divided by A equals R power T. Now take the square, not square root, root of this number. That's it. That is the answer. Now imagine you had been given, say, final amount is 10, initial amount was 5, and R is, say, rate is something unknown, but the time is time. Wait, let me make this as yeah, let it be anyways. Let me make this 20, okay? So it's easier. And this one over here as square. So I'll first find 20 by 5 is 4 equals r square. Now I take square root on both the sides. This cancels. The answer is 2 equals r, right? This is what I'm doing. Now the root must be taken to this term. Let's just check the answer. Okay, they are telling divide the final amount by the initial amount. Yes, we did that. Divide this, just take it over here, right? A to the other side. You're dividing the final amount by initial amount, and then the n is the number of time interval that passes. They have taken this time t as n. That's fine. We have taken as t. Nth root, we have taken t time as t, right? The tth root, or if they take it as n, nth root, take the nth root. That's it. That's the correct answer what we got. It is square root t, the time interval, divided of y by a, where y is the final amount, a is the initial amount. This is how we can solve it. If you know this formula, this is a formula which is given for the rate. You might have come across this. That's the final amount into initial amount multiplied by the exponent. What is that exponent? Rate to the power time. Uh, that's it. That's the end. We have finally come to the end of all the EOT questions for the grade 11 elite. I'm sorry for the delay. There was a delay when I was uploading all because of certain unfortunate circumstances. But anyways, I hope you have some time at least to go through them. I hope as I was publishing them, you could have gone through them. And all the best, guys. I hope your exam will be easy. I hope you're prepared well. Take enough rest and make sure you are well refreshed before the exam. And take it easy. Make sure you recollect whatever you have learned and try your best in the exam. I hope everyone gets great marks. Take care and wish you all the best and happy learning.